In the previous lectures, we have studied about message passing systems and shared memory systems, which were two strategies that were used for communication between processes. So the message passing system and shared memory systems can also be used for communication in a client-server-based system. And in this lecture, we'll be studying about sockets, which is also a strategy used for communication between processes. And this is mainly used for client-server-based systems. So the sockets are a strategy that is used for communication in client-server systems. Now let us see what are these sockets, how do they work, and how do they help in communication between two or more processes. So first of all, let us see what is a socket, or how can we define a socket. A socket is defined as an endpoint for communication. So how we can define socket is, it is defined as an endpoint for communication. So when two processes or two systems want to communicate with each other, sockets are the endpoints on either end of the communicating processes. So a pair of processes communicating over a network employ a pair of sockets, one for each process. So as I told you, when two processes wants to communicate, there needs to be a connection between them, and at each end of the connection, each of these processes will employ a socket each. So a pair of communicating processes over a network will employ a pair of sockets, one for each process. Now we will see how can we identify a socket. A socket is identified by an IP address, concatenated with a port number. So a socket is identified by an IP address. Every socket will have an IP address, concatenated with a port number. That means it will be followed by a port number, so it will have an IP address. And following that, it will have a port number. So that is how sockets are identified. So I'll be showing you examples of this as we move further. But for now, you remember that sockets are identified by an IP address followed by a port number. Now let us see how does a communication between these processes employing a pair of sockets take place. So what happens is, the server waits for incoming client request by listening to a specified port. Once a request is received, the server accepts a connection from the client socket to complete the connection. So first of all, let us understand what is client and server. You may already know, in a client-server systems, the client asks for information from the server, and the server will give that information to the client. That's how it works. So in order for the client to communicate to the server, and the server to communicate back to the client, there needs to be a connection between the client and the server. So in order to establish this connection, we are going to use the sockets. And as I told you, sockets are identified by an IP address, along with a port number. So what the server does is, it waits for incoming client request by listening to a specified port. So each process will be associated with a socket, and that socket will be having a port number. Now the server, it listens to the port, waiting for some incoming client requests. And once a request is received, that means once a client is trying to communicate to the server accepts the connection from the client socket to complete the connection. So once the server receives the connection request from the client, what it does is it will accept that connection from the client circuit to complete the connection. So once the connection is established, they can now communicate with each other. And remember that, at either ends, at the server's end and at the client's end, with both the processes, there are sockets, and the sockets are the ones that will enable this connection to be established. Now moving forward, servers implementing specific services, such as Telnet, FTP, and HTTP, listen to well-known ports. For example, a Telnet server listens to port 23, an FTP server listens to port 21, and a web or HTTP server listens to port number 80. So as I told you, socket is identified by an IP address followed by a port number. So a port number is going to identify each of the processes or each of the services that are going to be provided. Now servers, which implement specific services such as Telnet, FTP, and HTTP. These are specific services that are implemented by servers. Like for example, Telnet, it is used for remote login. Then FTP stands for File Transfer Protocol, which is used for transferring files. And HTTP, as we all know, it is Hypertext Transfer Protocol. So these are certain services that are implemented by servers. And these services, they listen to specific ports. There are specific port numbers that are reserved for these specific services. So Telnet, it listens to port 23, FTP server listens to port 21, and the HTTP server listens to port 80. So these port numbers are reserved for these specific services, and these port numbers cannot be assigned to some other client, processes, or any other processes. So we should keep that in mind. And it says here that all ports below 1024 are considered well known, and we can use them to implement standard services. So just like I showed you before, like Telnet, licensed to port 23 FTP 21 and HTTP 80. Similarly, all the port numbers below 1024 are reserved for specific services. Alright, so what we mean by this is, whenever we want to assign a port number to the client process or any other processes as such, we should not use port numbers below 1024 because most of the numbers below 1024 are reserved for standard services, like the ones that I showed you before. Now moving on, let us take a visual example and see how does communication using sockets takes place. So here in this diagram, I have this first part, which is the host, and I have the second part, which is the web server. Think of this as the client, and this as the server. So the client wants to request something from the server, and the server has to fulfill that request by giving whatever the client asked from the server. So in order for that to occur, we need to have a communication link between this server and the client. There has to be some kind of link between the server and client. So in order to establish this communication link, we are going to use the concept of sockets, which we have just studied. So let's see. This is the socket that belongs to the client. So when a client process initiates a request for connection, it is assigned a port by the host computer. So here a client process is trying to establish a connection between the client and the server. So what will happen? The host computer will assign a port number to this process, which wants to communicate to the server. So if you look at this, this is the IP address of the host computer, 146.86.5.20, and a process that belongs to this host computer wants to communicate to the web server. So what will happen? A specific port number will be assigned by the host computer to this client process. So if you look at this, this is the IP address, which is same as the IP address of the host, and it is concatenated with a port number. So as I told you, sockets are identified by an IP address, followed by a port number. So this first part is the IP address, and the second part is the port number. So this port number is some arbitrary number greater than 10 to 4, and why should it be greater than 1 to 4? Because the port numbers below 102 are considered well known and are used for implementing standard service, as we have already seen that. So whenever port number is assigned to process, it has to be something greater than 1024. Like for example, here we have used 1625. So here the socket is established, and similarly in the web server, here this is the IP address of the web server, and this web server also has a socket, and that socket belongs to the process in the web server that is going to communicate with this client process. So here also we see this IP address is same as that of the web server, and here we have port 80 assigned here. And when you look at port number 80, you know that it is less than 1024. That is because this is the server, not the client. So this client is trying to access some services from the server. So this port number 80 belongs to some standard services, which is there. And this client process is trying to access that. So the package traveling between the host are delivered to the appropriate process, the destination port number. So the packets that are traveling from this client process to the server process are delivered appropriately based on the port numbers So here there is a standard service with port number 80, which this client process with port number 6 to 5 is accessed to, and then their connection is established, and the package will be delivered to and fro accordingly. All right, now let's say that another process from this host computer wants to communicate to this same socket of this process in the web server. Then what will happen? That process will again be assigned another socket, and that socket number should be something different than 1, 6 to 5, and again, it should be something greater than 1, 0 to 4, and y should not be 6 to 5 because 6 to 5 is already assigned to this particular process. So it should be assigned some other number, and make sure it should be above 102. And similarly, the connection will be established between the circuit of that process and the web server, and the communication will take place. That is the way how communication takes place using sockets. So this is another strategy that is used for communication between processes, and this is very specifically used for the client-server system. So in the previous lectures, we have studied about message passing and shared memory systems, which are also types of communication between processes, and they can also be used in client-server systems and also in other systems. But the sockets are specifically used only for the client-server-based systems. So with that, I hope the concept of sockets are clear too. Thank you for watching, and see you in the next one.